standard hardware, standard traditional storage. But as we grew and grew, we've seen more and more need for deeper visibility, more granular control, and the scalability of trying to do these things with traditional storage became a little more difficult than we thought. So in our cloud, everything that we do is replicated between our data centers to provide a highly available VR solution for customers. And what we were seeing is the ability to replicate whole volumes of storage efficiently between data centers became more and more difficult as customer demand grew. So a customer changing one VM would impact the ability to replicate the whole line and thus cause us missing SLAs on other VMs. So we started looking at what our next generation solution to this problem was. So we were looking for something that would reduce our overall cost, give us the ability to have granular control over the not only the policies of the VMs, but also visibility into the VMs, as well as perform very, very well. This led us, in conjunction with ClearSky, to their solution, which was a service-based offering in conjunction with vVols.
Thanks, Tim. So the ClearSky solution is what we call a global storage network. It is a system that end-to-end allows you to consume storage at primary storage speeds, feeds, and performance. However, also provides you the economics of cloud. And the way we do this is to leverage metro area points of presence in multiple locations in the country in order to control latency. And from those metro areas, we provide connectivity into customer data centers to offer them an endpoint, a protocol endpoint for vVols that basically manages all of their storage needs. So you get primary storage performance, you get DR built into the service, and you also have backup capabilities also built in. So end to end, you're simply consuming a wire. And along with that, of course, because it is a service, we offer a very, very tight SLA to include such things as uptime, performance guarantees, and operational consistency. So how do we do this? This diagram is a diagram of our architecture. As I mentioned before, it's really a three-tier architecture. The key to remember is what happens in the metro area is by far the most important. Latency is very, very important when managing remote storage, and so we want to be within a millisecond or two of every customer. So hence we're setting up in very densely networked data centers in large metro areas, and we're building out our infrastructure from there. We're building out in Philadelphia, of course, where Xtium is headquartered. And what we do there is we build out a very, very interesting software-based storage stack that is multi-tenant. It's all flash-based, and we also attach a good deal of warm cache. So customer data lives in this point of presence and is protected in this point of presence. Going out from that point of presence, we run private connectivity into our customers' data centers, and this includes the Xtium data center as well. We have high-speed Ethernet connectivity that's dedicated to the storage traffic, and it is also redundant. So we manage diversity and we manage throughput by making it a dedicated connection. On our front end, we are offering a protocol endpoint, which is vVols enabled. And one thing that we should point out is that it's actually built from the ground up. This is not a legacy storage system. We built it ourselves to accommodate the needs of vVols. vVols are a very interesting technology because they solve a fundamental management problem, but they create potentially another fundamental system problem that we've solved in our infrastructure. You can have an awful lot of vVols because you have an awful lot of virtual machines out there. So we have already built in the scalability that's necessary in order to have hundreds of thousands of vVols that can be managed through one of our endpoints. The Edge appliance, which we provide our customers, sits in their cage. It's a single appliance. It looks like a SAN device. We support iSCSI, but it's only 2 units, full flash, and you get a very, very high level of performance as a result. From there, I should also point out that we have the VASA provider and also the protocol endpoint built into the high availability infrastructure. So unlike a conventional storage array that has an off-board VASA provider, we provide high availability end-to-end for the system. In the back end, we also have dedicated connectivity into major public clouds. And this becomes the durability component of the system. We basically manage all of your data end-to-end, and the durability of the clouds is leveraged so that we can change the economics of the storage system such that you don't have multiple copies. You simply have a cached copy of your data at a location that's closest to you, and you get the experience of primary storage without having to worry about managing things like failed devices, failed RAID sets, and all of the infrastructure that's required in order to scale out storage infrastructure. And then there's one additional benefit that this architecture enables, which is the notion of workload portability. Inside of a metro area, the global storage network appears as though it's a single protocol endpoint. It's a single geographically dispersed storage array. What this means is that if you have multiple data centers in a particular geo, we can actually move your data from one data center to another transparently. This allows you to do very interesting things such as metro clustering, failover scenarios, and also some very, very interesting hybrid cloud scenarios, which are very germane to what Xtium is doing with our service.
So in testing so far with ClearSky and vVols, we're seeing enterprise level performance. We have deep visibility into VMs to provide both to our engineers as well as our customers. So granular metrics on change rates, I/O performance at a per VM level, as well as the ability to manage it now with policy. So now we can choose individual VMs to move and have portability between our data centers to make snapshots or copies of, and we're not burdening ourselves with just doing entire volumes or runs. The data portability that Laz mentioned is been very interesting because we have both kind of a hot mode test within a local metro, but also we've been testing now even portability across the country where it's a minimal amount, literally minutes of downtime to get a full multi-terabyte workload from being presented on the East Coast to being presented on the West Coast without us having to replicate it at all, which is a huge advantage to us because now we can have sub-hour RTOs, RPOs to bring up workloads anywhere in the country without having the burden of having to replicate the data. And overall, the TCO of the storage has been, frankly, remarkable. Just in being able to purchase it as a service, the granular visibility with vVols, eliminating some of the inefficiencies of storing things on a volume level, as well as the reduction in our overhead for engineering staff to kind of manage all the replication stuff, we're estimating is saving us between 60 and 70% on storage right off the bat. And that's before we've really dug into optimizing the process. So it's been working very well so far, and we're looking forward to moving all of our tens of thousands of workloads to vVols as soon as we possibly can.
So I have a demo here of the workload portability portion of our functionality, and if you bear with me, I will try and... So I should start by basically telling you that we have all of this stuff running live in our booth, 441, down in the Solutions Exchange. So feel free to visit us and see the stuff live. We have a full provisioning user interface and all, full storage functionality that we can show you, including a vSphere plugin. What I'm going to show you here in this demo is really one of the more unique capabilities that we have, which is the ability to move a workload. This is what we call a live view, and you know, inside of a metro you actually have a view of all of your storage. We're going to actually move a set of vVols across from data center A to data center B in this demo. And as you can see, it's a very, very simple you know, two-step configuration. One of the things that we do is we do warn you that we're going to start messing with your workloads, but it's simply like a three-step process. And you can see the volumes move from data center 1 to data center 2, and the protocol endpoint has been reconfigured. A rebind command has been issued, and your workload is now suddenly visible in the other data center. So this is one of the capabilities that we have inside of a local metro, and you know, as Tim mentioned, we also have capabilities across metros that are point-in-time based, and we also have a full storage management capability. So this looks like a conventional storage array to you as you're using it. So